Dear students, welcome to the lecture series on the topic engineering graphics. So today we are going to discuss about standards for engineering drawing. I am Dr. IPS Ahuja, Professor Mechanical Engineering Department, Punjabi University, Patiala. So as we have already discussed that engineering graphics or engineering drawing, it is the language for communication amongst the engineers all across the world. So this language would be understood by one and all only when if this language of communication remains same and it follows the given set of standards irrespective of the country that we are going to draw or read or understand any given engineering drawing. So first of all, we need to understand what do we mean by these standards. So the standards basically they are the set of the rules which govern that how the technical drawings they are represented, how the technical drawings they are prepared, and how the technical drawings they would be understood in all parts of the world. So here you can see, for a reference, we have got an engineering drawing, and here you can see that there are lots of different types of lines which have been drawn over here, but each and every line it carries a different meaning. So as an engineer we need to understand what is the meaning of each and every line. You can see over here there are dark lines, there are hatching lines over here, so there are chained lines which we have drawn. These are representing the centers. Similarly, you have the center lines and all the different types of lines. And besides this, you have the extension lines as well as you have the dimension lines. So you need to understand what are the different types of lines. Similarly, lot of text is also written over there onto any given engineering drawing. So we need to understand how this text we are going to add onto any given engineering drawing. So this way we need to have proper set of principles which needs proper understanding. Only then we will be able to develop proper understanding of any given engineering drawing. So in this series we are going to see that what are different types of standards which must be understood by the engineers. So before we move on to that, so let us see what does these standards they stand for. So the standards, as we have discussed, they are the set of the rules that govern how technical drawings they are prepared and represented. So these standards they are established in most industries, schools, and the industrial organizations or the companies. And these standards they promote safety, reliability, quality, productivity, interchangeability, and efficiency of manufacturing. The standards they also offer us to lower the cost by minimizing the errors which might creep into the drawings if we are not following those standards. And besides that, these standards they also simplify the training of the engineers in all parts of the world. And uniform standards across all parts of the world in the different countries they have been established, and they need to be understood by engineers all across the world. And what are those standards? You can see every country is having their own standards. They are naming it as per their country's origin, but the basic concept behind all those standards it remains the same. So you can see that the first standard is ANSI. So ANSI stands for the American National Standards Institute, but the components which are there in ANSI they will be same components will be there under the ISO, under the JIS, that is the Japan Institute Standards, as well as BIS. So BIS stands for the Bureau of Indian Standards. So in whichever country you may represent, but the standards will remain the same irrespective of the country of the origin. So ISO is the universally accepted standard which is applied in many countries, whereas in India we are following the Bureau of Indian Standards which we call as BIS. So the different components of these standards, they will be standards related to drawing sheet and sizes and formats, line conventions and lettering, dimensioning and tolerances, and similarly you have standards for drawing board and specifications. The methods of projection, again they are governed by the standards. Then different drawing instruments which are being used in the engineering drawing, they are again governed by the international standards. Similarly, different types of scales. Now you see, most of the drawings we are not drawing on the drawing sheet on the exact size, because depending upon the size, let us say we have to draw the drawing of a building. Building is quite big as compared to the size of the drawing sheet, so there we may have to compress our drawing. So that is, we have to reduce the scale. So reducing the scale means we have to reduce the size of the building once we have to draw it onto the drawing sheet. Similarly, you may have, let us say we are wearing spectacles and there are screws over there. Similarly, you are wearing the watches. So even in the watches, etc., again you have the small gears, small screws, small spindles will be there. So those drawings, if you draw it onto the drawing sheet, now the sizes of the components, they are very, very small. So if you draw it as per the size, again you will not be able to develop proper understanding because of the smaller size of the drawing. So there what we do, we enlarge the size of the object which we are going to draw it onto the drawing sheet. So this is called enlarged scale drawing over there. Similarly, there will be certain other objects which are of normal shape. That is, we have the mouse with us, we have the normal pen with us or pencil with us. So those objects which can be accommodated within the size of our drawing sheet, we are drawing it onto the same size. So this we call as full scale drawing. So this way, different types of scales we are going to use on the engineering drawings. So they are again governed by our international standards. Similarly, you have the dimensioning practices. So here you can see in the previous drawing over here that we had, so all these dimensions or the sizes of the objects, they have been mentioned onto the engineering drawing, and this is again governed by the set of standards of the engineering drawing. So in case of India, as I told you, we are going to use the BIS standards. Now in India, we started with BIS SP 46 1988 standards, and the name of those standards was Engineering Drawing Practice for Schools and Colleges. Now this was used specially for the educational institution purposes and even in the industries, and these standards were related to engineering drawings or engineering graphics over there, and they have been refined or revised latest as BIS SP 46 2003, and even they have been further improved to BIS SP 46 2014 standards. And these are the different components of the engineering drawing standards which we are going to study one by one during the course of this particular lecture. So here you can see, this is the book or the standard which you can download from the Google as well. So these are the BIS standards. I'll just show you over here. This is one set of standard of 2003. So I'm going to open this web link for you. So here you can see, this is the standard available with us. So this is the Indian standard which is accepted, and here you can check this out. This is for engineering drawing practice for colleges and schools over there, and you see the cost is 1440, but you can download it free of cost. And here you can check whatever issues we had mentioned over there, all these issues they are taken care of. That is sizes and layouts of the drawing sheets, then planning of the assembly drawings, folding of the drawing prints, scales, lines, lettering, projection methods, and all the other things. So all the basic standards, these standards we are going to take up during the course of this particular lecture. So this is the standard for BIS SP 46 2003, and similarly these standards, they have been revised in 2014. So these are 2014 standards which are again available on the website on the Google, and if you wish you can download the copy of these standard. They are again one step advanced as compared to the 2003 standards, but again they will contain the same things. So maybe more elaborations they have been added. So just see, as I told you that even the instruments, they are also covered under these BIS standards. So how we are going to use it and what are the different specifications, they are all covered under the BIS standards over there. Now we are going to start with that what is the basic objective of using all these instruments. So the basic objective of using these instruments is that is to improve the accuracy of the drawing, to improve the speed of construction of the drawing, to improve the legibility of the graphical construction which we are going to prepare and represent onto the piece of the drawing. And moreover, these instruments, they promote neatness of the drawings which we are going to prepare onto the drawing sheet. So the first standard which we are going to pick up over here is our drawing sheet. How the drawing sheets, they are going to, what are going to be the different sizes of the drawing sheets, how we are going to go about managing our drawing sheets, what are the different components of the drawing sheets, all these things we are going to discuss now. So the drawing sheets, they are covered under the BIS standard 10711 of 2001. So these are the standards which are recommended by BIS. Now the drawing sheets and the paper, they are the canvases on which the drawings, they are composed by pencils or pens. So the drawing sheets, they are available in the standard sizes. Now you can see these are the different sizes of drawing sheets. They start from A5, A4, A3, A2, A1 and A0. Now the A4 sheet we are usually using because this size is used in our day-to-day work regarding all our Xerox that we are getting. So the standard size of A4 sheet is 210 by 297. So this is our standard A4 sheet which we easily recognize in our day-to-day work. So what we do, you see, if we club two A4 sheets along the smaller side, so 210 if we combine, so we are going to get one big A3 sheet over here. So in the A3 sheet, what we are going to get, so if two A4 sheets, they are placed side to side alongside the smaller dimension, we are going to get realization of the A3 sheet. So this I will be showing it to you graphically as well. So the size of the A3 sheet becomes 210 multiplied by 2 gives us 420 and 297 becomes the smaller size. And now we have got one big A3 sheet which composes of two A4 sheets which are arranged along its smaller lengths over there. Now since the smaller length was doubled, so it becomes the bigger length, whereas the bigger length of the A4 sheet becomes the smaller length in case of the A3 sheet. Now if we arrange this A3 sheet along its smaller length, so if we multiply it twice, so what we get, that is 420 is the bigger length, 297 is the smaller length. So smaller length if we double and we put two sheets across side by side, so we get the formation or the formulation of the A2 sheet. So A2 sheet will get 297 was the smaller side, so 297 multiplied by 2 gives us 594, and which becomes the longer dimension now, and this longer dimension of the A3 sheet becomes the smaller dimension of the A2 sheet over there. So if we repeat the same practice twice, we are going to get the realization of the A1 as well as A0 sheet, but there will be only one difference, that if we multiply 420 into 2, so in the final sheet there is a margin of 1 millimeter along the longer dimension. So here you can see 420 multiplied by 2 gives us 840, but since I told you there is a margin of 1 millimeter, we get along the longer side 841, whereas 594 remains same in case of A1. And similarly, if we put along two A1 sheets along their smallest dimension over there, then 594 into 2 gives us 1188, but again there is a margin of 1 millimeter over there. So the final dimension we get as 1189 multiplied by 841. So these are the trimmed sizes of A4, A3, A2, A1 and A0 sheets. But if we have to trim it from the bigger sheets, so these are the untrimmed sizes. So we don't need to remember the untrimmed sizes, because we are going to use the trimmed size sheets for the purpose of preparing any given engineering drawing. So let me demonstrate it to you. How do we arrive at A0 sheet starting from A4 sheet? So here you can see these are the A4 sheet size which is given over here. Now, as I told you earlier, this is one A4 sheet whose size was 210 by 297. So in any given sheet there will be one longer dimension which we call as L, whereas there is one shorter dimension which we call as W. And for all these A0, A1, A2, A3, A4, A5, A6, A7 and A8 sheets, there is definite relationship between length and width. The length of every sheet will be under root 2 times multiplied by its width. So now we have started with A4 sheet, and as I told you earlier, in A4 sheet there is one bigger dimension, there is one smaller dimension. So if we put along two A4 sheets along their smaller dimension, which is the smaller dimension 210. So if I add one more A4 sheet, this is going to give me one A3 sheet as a whole. So if we combine two A4 sheets along their smaller dimension, now the size of A3 sheet you can see over here, 297 remains same, and 210 and 210 gives me 420. That is, the smaller dimension multiplied by 2 gives me the bigger dimension of the A3 sheet, whereas the bigger dimension of A4 sheet now becomes the smaller dimension of my A3 sheet. You can check, this is the size of my A3 sheet. And how it is obtained? It is obtained by putting together two A4 sheets along their smaller dimensions side by side. So this gives me the A3. Now from A3, if I want to derive A2 sheet, so how I will be doing it? Now this is the size of the A3 sheet combined. That how much is that? 420 by 297. So here you can see A3 sheet is 297 by 420. Now in this longer side is 420 and the smaller side is 297. So this is the smaller side now. This is the longer side. Now I will place two A3 sheets along their smaller dimensions over there. You can see now the A2 sheet will be obtained when I add one more A3 sheet alongside my previously available A3 sheet along its smaller dimension. So the smaller dimension was 297. So 297 and 297 gives me 594, which becomes my bigger dimension. You can check, this is the bigger dimension 594 and this becomes my smaller dimension 420 over here. So this gives me construction of A2 sheet. Now once I get A2 sheet, you can check the size 420 by 594. Now I want to get the formulation of A1 sheet out of this. So what I will be doing, in this sheet 594 is this one, which becomes my bigger dimension. This is my 420, which is my smaller dimension. Now I will be adding this A2 sheet, one more A2 sheet alongside its smaller dimension over here. So once I add one more sheet, now I told you that there is a margin of 1 millimeter. So 210, 210, 210 and 210 means it doesn't become 840, it becomes 841, because in the final A0 sheet 1 millimeter excess is there. So this gives me the size of the A1 sheet, in which 420 plus 420 gives me 840. So margin of 1 means it is 841, and this 594 was bigger earlier on and this becomes the smaller dimension now. So this gives me size A1 sheet, which is 841 by 594. Now I want to realize this sheet, that is A0. In A0 sheet, what is there? Now it will be derived from A1. In A1, 841 was the bigger dimension. You can see this is the bigger dimension, and this was 594, which was the smaller dimension. So this is complete sheet is A1. So I will now arrange one more A1 sheet and arrange it alongside its smaller dimension, so that the smaller dimension becomes doubled over here. So just check it out. I am adding one more sheet of A1, and now this doesn't become 594 into 2, that is 1188, because there is a margin of 1 millimeter. So one more I add, and the final size of A0 sheet becomes 841 by 1189. So this means that from a bigger sized sheet, if you fold it across the longer dimension, you are going to get two smaller size sheets, or vice versa. If you have a smaller size sheet, you put two sheets together along the smaller side dimension, you are going to get realization of the bigger size of the sheet. So this is how the nomenclature of the different sheets they go. And this is again one of these common practices, how to derive smaller sheet from a bigger one or a bigger sheet from a smaller one. So let us see. This is my A0 sheet. In A0, this is the smaller dimension, this is the bigger dimension. If I fold it along its bigger dimension, I get two smaller ones. So D is my A0 sheet. From D, I get two A1 sheets. And once in the A1, again, this is my bigger dimension, this is my smaller. Again, you fold it along the bigger dimension, I get two smaller sheets. Again, this is the next sheet, that is A2 sheet. From A2, this is the bigger dimension. You fold the sheet along the bigger dimension, you get two A3 sheets over there. Into the A3, once again, this is the bigger dimension, which is our 420. And if you fold it along 420, you get two sheets of the A4 size. So this way, you can see that from every bigger sheet, two smaller sheets they can be derived, or vice versa. If you have two smaller sheets, you put them together along their smaller dimensions, you can realize the bigger dimension sheets. But irrespective of whichever sheet we are talking about, in every sheet length will be equal to under root 2 times the width of the sheet. So if you multiply under root 2 by 210, you are going to get 297. Multiply under root 2 by 297, you are going to get 420 mm. Similarly, you multiply under root 2 by 420, you get 594 millimeters. Same thing applies from A8 to A0 sheets. And let us see what are the applications of the different sizes of sheets. If you are using A0 sheets, the common applications are posters over there. A1 sheets, they are usually used for flip charts as well as newspapers. A2, A3 and A4 sheets, they are used for engineering drawing. And A4 is common standard sheet which is used for letters, printouts, and we are using it day in and day out for our xeroxing purposes. A5 is used for notepad, usually used by the businessmen in their businesses. Then A6 is used for smaller bills. Then A7 is used for index cards. And the common playing cards which we are using, they are made out of A8 size of sheet. So every sheet is basically derived by the lower end of the sheet is derived by folding the bigger sheet across its middle part. So this is how we are going to derive any size of the sheet. Now next standard is related to the drawing board. Now the drawing board is basically made out of the wood, and the basic purpose of the drawing board is to support and hold the sheet properly so that we can go in for manual drafting using the mini drafter over there. And another requirement of the drawing board is that it should be made out of the soft material so that even if any pins are to be inserted, so we can insert the pins over there so that we can hold the drawing sheets onto the drawing board. So nowadays we are not using the drawing pins, rather we are going in for the sellotapes, so to hold our drawing sheet onto the drawing board. So drawing board, again, it is governed by the specification and sizes. They are governed by IS 1444/1989, which is again given by BIS. So this is the manual drawing board which we can hold it anywhere. You can use it onto your bed or anywhere, whereas this is the standard drawing board which we are using into our engineering graphics labs. So similar to the drawing board, drawing sheets, so there are standard sizes of the drawing boards, and another requirement of the drawing board is that it should be uh, longer and broader than the sheet it has to hold. So since A0 was our largest size of the sheet, similarly D0 is our largest size of the board. So this size is 1500 by 1000 and 25 is our width. D1 size drawing board, this is 1000 by 700. So there 50% principle does not apply as it applied to the drawing sheet. What is this 50%? That is, you have the larger side, divide by 50% gives you the smaller size of the board. No. So because drawing boards have to be bigger, so we are not following the same specifications for drawing boards. So the D0 size is 1500 by 1000, length is 1500, width is 1000, thickness is 25. D1, length is 1000, width is 700 and the thickness is 25. Then D2 size, this is used to hold A2 size sheet and its size is 700 by 500 by 15. Similarly, D3 is the smallest board and its size is length is 500, width is 350 and thickness is 15. So here you can check that for the larger drawing boards, the thickness is higher, whereas for the smaller drawing boards, the thickness is 15 mm. Now the reason behind this is the smaller drawing boards need not be that much sturdy, whereas the longer drawing boards, there may be problems regarding warpage or bending. If the thickness is lesser, they may break out very easily. So in order to avoid that, the thickness of the larger D0 and D1 drawing boards has been increased to 25 mm as compared to the thickness of D2 and D3 drawing boards, which was 15 millimeter over there. Now this is our common drawing hole which we are having in most of our engineering institutes. Now this is T square, which is used on the drawing boards to give you parallel and the perpendicular lines. You see, this was used earlier basically. Nowadays we are not using it because we are going to use mini drafter nowadays. But T square, basically it is a T-shaped device which was used earlier on around 10 years back to draw the horizontal lines. Right now we are not using it any longer. So this is how we were using it. So we were moving it alongside the dimension of our, alongside the boundary of our drawing board, and we were able to get parallel lines as well as the perpendicular lines. We were using the set squares alongside T square to draw the perpendicular lines over there. Now nowadays what we are doing, we are using the mini drafter. So this is the construction of the mini drafter, and this is the scale. L-shaped scale is there, and then there are graduations of the degrees over there which are going to give us the rotation or the protractor basically component of our engineering drawing. So here we have the L-shaped scale which we are going to use to draw parallel and the perpendicular lines onto any given drawing sheet. So how to use mini drafter? So this I will be describing by having a separate video so that you can develop a better understanding how we do the clamping of this mini drafter onto the drawing board. But I'll just show you over here, brief introduction I'll give you over here, but detailed description I am going to take up in a separate video lecture. So this is how you see we are going to use our mini drafter. So this clamp we are going to use somewhere here, so that this knob has to be tightened to maximum level so that it should not loosen up at a later stage. Similarly, again there is one knob over here, and this is the graduated, you see, angular scale onto which the zero marking will be there onto this steel part. So this zero will be marked alongside a cut which is provided onto this metal portion, and only then we are going to tighten this particular knob over here. So you are going to get construction of the parallel and perpendicular lines perfectly only when this knob and this knob is tightened perfectly. If either of this or this one, this knob is loosened, so your scale will get distorted, it will get loosened up, it will get disturbed, and you will not be able to draw parallel or the perpendicular lines using this mini drafter. So the basic objective of this mini drafter is to facilitate ease of drawing different types of lines onto our drawing sheets. So this is the basic purpose of the mini drafter. So you can see we are going to usually hold the mini drafter on the left most upper portion of our drawing board. Along this corner we are going to hold it. So tighten this one. Once you set this to 0 mark, again tighten this knob. Once these two knobs they are tightened perfectly, you will be able to draw parallel and perpendicular lines perfectly and conveniently onto your drawing sheets. So this is how we are going to use our mini drafter. Now another set of, you see, instrument which we were using earlier not using nowadays, it is called roller scale. So here you can see there is a roller and there is a scale. Now you can roll this scale onto your sheet, and once again you can get parallel or the horizontal or the vertical lines drawn onto your drawing sheet. So this was again one of the its use is similar to the T-square. So either you can use T-square or you can use the roller scale to draw parallel and the perpendicular line. But nowadays we are using the mini drafter. Now in order to draw different angles, we are using set squares. Now set square, you can see there are two set squares. One is 45 set square. Another one is 30 degree, 60 degree set square. So this is 90 degree. This is 45. This is 45, which makes it 180. Similarly, this is 90. This is 60. This is 30. So you can use both of these protractors, set squares, in combination to derive different angles in the intervals of 15 degree. So this is how you can draw the angles quickly. Another method is if you have to draw a specific angle other than 15 degree, you see, breakup, then you can use this protractor to draw the angles onto your drawing sheet. Now this is the combination which I was telling you, that how you can work upon this combination of the set square to get easy angles without using the protractor, but here the increments are of 15 degree each. So from either side you can use these in set squares in combination, in tandem combination, so that angles of 15, 30, 45, 60, 75 and 90 can be drawn with minimal ease, with maximum ease. Now this is the instrument box, which will contain the compasses, which will contain the inking pens, which will contain the dividers and the lead. Nowadays you see the compasses we are using, you can see over here there are two types of compasses which we have listed into this instrument box. One is large compass. It is used to draw circles up to 100 mm radius. Similarly, there is a smaller compass which is used to draw circle up to 55 mm radius over here. And if larger radius are required, then we are using the lengthening bar. So here you can see the compasses. So the basic purpose of compass is to draw circles or the arcs. So as I told you, we are using two sizes of compasses. One is the large compass, another one is the small compass, which we are using. Now this compass, this is called engineering compass, and this compass is different from the one which we were using in our class 8th, 9th or 10th. In those compasses, we had a hole and we were putting up our simple HB or 2H pencil over there to draw a circle. But the problem with that compass was that pencil used to be moving around little bit, and because of that, because of small swaying away of the pencil into the slot, because of the poor tightening ability of those compasses, there was inaccuracies which were obtained and which were observed while drawing different types of arcs and the circles. So that is why we have improved upon this design, and here you can see you don't have space where you can add the pencil. So what we are going to do here, so we are going to add a lead over here. We are going to have a sharpened lead. You are going to get bigger lead sticks, which I will be just showing you in a while, and those lead sticks we'll be just cutting them up, and we are going to sharpen those lead sticks using the emery paper or using a cutter blade, and those leads we are going to insert over here. And once the balancing is done, we'll be able to, after tightening this knob or the screw, we'll be able to get perfect construction of the circles of the arcs. Now, as I told you, bigger compass can be used to draw circles up to 100 mm. Smaller compass over here, it can be used to draw circles up to radii of 25 mm. But if diameters greater than 150 mm are to be drawn, then we can use this lengthening bar. So over here we can add the lengthening bar, and using this we can draw up to 150 mm radius circles or the arcs over there. Similarly, this is the application. You can see the lead we have inserted. This is the lead which has been sharpened and has been inserted over here, and this is the addition of the lengthening bar or the extension bar. So this way 25 mm radius you can draw by using the smaller size. This is the smaller size of the compass. 100 mm by using the longer compass, and up to 150 mm you can draw it using the extension bar. Now these are the lead sticks which I was talking about. You can cut it over here, sharpen it, and put it into the slot which is available over here, over here, over here, over here, and over here. And once you sharpen it, put it over here, you can use it for quite a bit period of time. Similarly, another instrument is divider. So in engineering drawing, we are required to transfer the distances from one location to the another. So in order to transfer those distances, we have to use the divider. Again, dividers are of two types. One is a large divider, another one is a small divider. So if the repetition of any dimension is to be done, every time I am not going to measure the dimension and transfer it. So I will measure the dimension once, and every time the same dimension is to be drawn at any other place into my same drawing, I will be measuring it using the divider and mark the distance using the divider onto the another location where the same dimension is to be reproduced. So basic idea behind using the divider is to improve the accuracy as well as the repeatability in the drawing. Now in engineering, up till now we have been using HB pencils in our 10th, 11th, 12th or 8th, 9th or 10th. But now in engineering, because there will be different types of lines, there will be certain lines which have to be drawn dark, there will be certain lines which have to be drawn with medium thickness, there will be certain lines which have to be drawn light. So these lines, they carry different meaning that we are going to discuss in a separate lecture. Now, but we need to understand, if we have to draw thicker line, medium thickness line, lighter line, so how we are going to use different types of pencils. So same pencil cannot give you the desired results to draw darker impression, medium impression, or the lighter impression. So what we have now, we have three categories of the pencils over here. One is medium pencil. So the medium pencil will be our HB pencil. If we have to draw the lighter impression, you can see we move from HB to H, 2H, 3H, 4H, 5H, 6H, 7H. And if we have to draw the darker impression, we move from HB to B, 2B, 3B, 4B, 5B, 6B, 7B. So what is the difference? As we move from HB to higher values of H, what is happening is the hardness of the lead which is there in the core of our wooden pencil, this hardness of this lead will be increasing gradually. So as the hardness of the lead increases gradually, what happens? It does not wear out very fast onto our piece of paper or our drawing sheet. So what happens? It keeps on giving lighter, lighter and lighter impression. So if you want to have very light impression, you can go to 4H or 5H. If you want to have medium lighter impression, it can be 2H or 3H. So marginal lighter impression compared to HB, you can use H pencil. Similarly, if you want to have a darker line compared to HB pencil, you keep on moving from HB to B, 2B, 3B, 4B, 5B. So as a beginner, what is happening in B grades? in B grades, whatever leads we are using, they are becoming softer and softer. So if we are using the softer leads, what is happening? As you just rub your pencil against the piece of paper or the drawing sheet and your lead is becoming softer and softer, it will wear out faster. So as it wears out faster, it gives you a darker impression onto your drawing sheet. So as a beginner, you see, we are all beginners. So as beginners, we are not using B, 2B, 3B or 4B pencils, because we may put more pressure onto our pencil and it wears out completely. And because it is a lighter, it is a softer grade pencil, so obviously it gives you the darker impression, so your sheet may get spoiled. So in engineering drawing for first year students, we are going to use HB pencil for darker impressions and 2H pencil for the lighter impression. So these are the two pencils which we are going to use for drawing different types of lines. So the darker impression, we are going to use HB pencil, and if we use it with lighter impression, we will get medium thickness, and if we are going to use 2H pencils, we are going to get the thinner lines being constructed using the 2H pencils. So even though the clutch pencils are also available, but we are usually not using clutch pencils for students. So we are using the normal wooden pencils over here. Now other instruments which we are going to use in the engineering drawing will be our sharpener, our blade, our cutter, our emery paper or our eraser, and usually we are using the non-dust good quality eraser so that it doesn't leave any mark onto our drawing sheet. So it should be non-dusting eraser. And usually earlier we were using clamps, drawing pins to hold the sheet, but nowadays we are using easy tear adhesive tape to hold the drawing sheet onto our drawing board. Now after this, you have your sheet container. If you wish, you can hold all your sheets into the sheet container, because the sheets should not get spoiled. If you are carrying all the sheets every time you come for the classes, it might happen that there may be dust all around your benches or desks in your classrooms. Your sheets may get spoiled. So it's better to have one sheet container in which you can have your sheets secured properly. Now after the drawing sheet, the basic sizes and the drawing boards and the instruments, now we will see how the nomenclature of the sheet will be there. So this is our standard drawing sheet, and you can see we have drawn the margins over here, and as you can check, sufficient margins should be kept on all sides of the drawing sheet. And another requirement is that the left margin of the sheet should be double as compared to the remainder three margins. So these three margins, that is top, bottom and right hand margin, should be 50%, whereas the left side margin should be double, that is 20 mm. What is the reason behind that? Because we ultimately have to secure our sheet properly and safely for longer durations of time. In the industry, we are holding our sheets into the file covers, and in the file covers we have the pins over there, we have the clamping arrangements over here, and we have to punch our sheets on this side, and because of the punching, the sheet is going likely to get damaged, it will be worn out. So that is why larger margin on the left hand side is usually kept. Then again, another thing you can check over here, on the bottom right hand corner we have got title block. What is this title block? Now this title block, basically it is a block which is drawn on right hand bottom corner of the drawing sheet in order to give you the detailed information of the drawing which is being drawn over here. In the industrial drawing, I am going to write the part number, I am going to write the name of the component, I am going to write down the method of projection, I am going to write down the tolerances, materials, I am also going to write down the scale over here, I am also going to write down who has checked the drawing, who has prepared the drawing, who has finally verified the drawing and approved the drawing. All this information will be coming in this title block. Whereas as a student, what we are going to write down? We are going to write down these information. That is the name of the institute, your name, your roll number, which sheet number you are talking about, what is the title or the chapter you are going, whether it is the projection of point, whether it is the projection of plane, whether it is the projection of solid. So your class section will be there. Now again you can see this is the method of projection. What is the scale which you are using over here, whether it is a full scale, is it a reduced scale, or it is an enlarged scale that we are using to prepare this drawing. And another thing we are adding, because all dimensions we have to write down onto our engineering drawing, and there may be hundreds of dimensions which we are putting down. Everywhere we are not going to write down 20 mm, 10 mm, 7 mm, 6 mm, 100 mm, 30 mm. So we will be writing down 10, 20, 30, 40, 60, and the units of measurements straight away we are going to put down into this title block. Now we will show you different orientations. Now you can check it over here. This was the landscape orientation. So irrespective of whether you are using your engineering drawing sheet in the portrait orientation or the landscape orientation, your title block location will be right hand bottom side corner. So here you can see, so this is your landscape orientation. In this landscape orientation sheet, your title block is at the bottom, and this margin will be double as compared to the remainder 3 margin. Similarly, this is the drawing sheet which is being used in the portrait orientation. So once again, left margin is double than the other 3 margins, and another one convention is, or the standard is, that the title block is once again drawn on the right hand bottom side of our drawing sheet. So here you can see this is an industrial drawing. So we have mentioned over there all dimensions in mm. So I am not writing down this is 14, this is 16, this is 20, this is 30. Whatever dimensions will be there, 35, 25, 125, 165. So all dimensions will be in mm. So everywhere mm need not be written. Similarly, you can check the scale. Scale is 1/2. What does this mean? This means that component is bigger by 50%. It means that I am drawing the component onto the piece of paper or the drawing sheet 50% of the size. If the component dimension is 200, I am going to draw 100 only. If the component dimension was 300, I am going to draw 150 only. So scale means that if the object is big, I have to scale it down, reduce the size to put it or appropriately fit it onto the piece of paper. Let us say the component is very small. If I draw it very small onto piece of paper, it will not be able to be understood by the other people or people who want to manufacture. So there I will be multiplying or enlarge my drawing. So there this scale will become 2:1 or 3:1. This is the method of projection. Again you can check, drawn by, checked by, approved by, on which date it was done, what are the materials, what are the tolerances, what are the surface finish levels. All this information will be available into my title block. So this is my sheet which is there into the landscape orientation. Now this is another one which is there into my portrait orientation. So orientations might change, but the location of my title block will always be right hand bottom side corner. And these markings, these 1 2 3 4 5 A B C D E, these markings are the folding point. I'll just show you in a while how the drawing sheets they will be folded so that they can be secured and kept safely for longer durations of time onto my files or folders or for the purpose of record keeping. Now on any given engineering drawing you can see these are the arrows. Every dimension will be labeled by using arrow. Arrow means it's going to give me a dimension line. So dimension start and end of the dimension line starts and ends with an arrow. So there are large number of arrows which we have to draw onto our engineering drawing. So Again, there are standard nomenclature for drawing an arrow. There are three types of arrows which you may have to use. One is an open arrow, another one it is a closed arrow, another one it is closed and filled arrow. So as students, we are not drawing closed and filled because here we have to rub our pencil multiple times. So lead may get deposited over here, and once you just move your mini drafter over this area, so this lead may spread to the other area. So usually as beginners in manual drafting, we are using these two arrows, but if we are using computerized drafting, so this is the arrow which we are going to use. Now what is the standard behind, what is the notion behind drawing this arrow? So the basic standard for drawing this arrow is that the length to width ratio of the arrowhead should be 3:1. What is this? This is the width of the arrow, this is the length of the arrow. So this length of the arrow should be 3 times the width of the arrow. So irrespective of whether you are drawing an open arrow or a closed arrow or closed or a filled arrow, the length has to be 3 times the width of the arrow. So this standard convention while drawing all these arrows must be followed in the engineering drawing. Now time in and time out, I am again talking about scales. So why do we need a scale? Very seldom we are drawing the object onto our drawing sheet of the same size. The reason is, in certain cases the size of the objects, they are very small, which will be hard for the users to understand it. So we enlarge the size of the drawing. Whereas on the other hand, let us say we have to draw the drawing of a fan, drawing of a tube light, drawing of a building, drawing of a refrigerator, so drawing of a curtain rod which may be 15 feet long onto our drawing sheet. So you are not going to have your drawing sheet 15 feet long. Similarly for civil engineering, the size of the building may be 20 story or 10 story. So you cannot have that big a drawing sheet so that you can draw the exact building or the construction onto the, or a bridge has to be drawn onto a piece of paper. So for that purpose you have to reduce the size. So scale down or the reduction has to be done. So what do we understand by these scales? So you can just go through this definition. The scale in engineering drawing, it is the ratio of linear dimension of an element of an object as represented on the original drawing to the actual linear dimension of the same element of the object. So whatever is the dimension which is drawn on the drawing divided by the actual size of the dimension of the object, this gives us the scale. So again, this is falling under the IS 10713/1983 BIS standards, which are scales for use in technical drawings. So here you can have a linear dimension, you can have a length, you can have the ratio of the area, you can have the ratio of the volume of a container. So this ratio will define whether you have reduced the size of the drawing compared to the object, or whether you are going to draw your object same size onto the drawing, or you are going to draw your object big on the drawing of the bigger size. So three scales are there. One scale is reducing scale. Reducing scale means that you are drawing the object smaller than the actual size of the object. So this scale will be 1 by x, 1 by 2, 1 by 3, 1 by 4. 1 by 4 means for 100 millimeter actual size of the object, size on the drawing will be 25 millimeter. Similarly, enlarging scale means that this ratio will be x by 1, 2:1, 3:1, sorry, 4:1, which means that if the size of the component is 2 millimeter, so I will be drawing it 4 times enlarged, that is 8 millimeter. I am going to draw it onto my drawing sheet. But for smaller object, let us say you have to draw your mouse, you have to draw your usual working pen or a pencil onto your drawing sheet. Now that can be easily accommodated onto your drawing sheet because the size of the object is smaller. So there, equal size, whatever is the size of my mouse, whatever is the size of my pen, whatever is the size of my glass over there, same size I am going to draw it onto my drawing sheet. So this is called 1:1. So this is called full scale. So here you can see Three scales we are using onto our engineering drawing. Reducing scales, for it is used for those objects which are bigger in size, which cannot be accommodated onto our drawing sheet at the same size or at the same level. So what we do, we reduce them by 50%, 25%, maybe 10%, or maybe even lesser than that. So these ratios will be, you can see reduction scale 1 by 2, 1 by 5, 1 by 10, 1 by 100, 1 by 1000, 1 by 10,000. So we are reducing our actual drawing as compared to the object, but make sure that all the dimensions will be reduced proportionately. If one dimension is reduced 100 times, all other dimensions of the object will also have to be reduced by 100 times. Full size means 1:1. Whatever is the size of the object, same size of the drawing will be obtained on the drawing sheet. Enlargement drawing, this is obtained for those objects which are of smaller size, and if we draw the very small drawings, it will be very hard for the people to understand it. So for that purpose we enlarge our drawing. If my size of my wristwatch knob or a pin or a screw over here or a gear over here, it is 3 millimeter, I cannot draw a drawing of 2 millimeter or 3 millimeter. So what I'll be doing, I'll be multiplying this by 10 times or 20 times. If my pin is of 2 millimeter, I'll draw it 50 times bigger. I'll draw a pin of 100 millimeter, so that whatever cuts, whatever creases are there, whatever special characteristics are to be prepared, whatever holes are to be prepared over there, all those things should be easily elaborated to the person who is going to manufacture it. So that enlargement scales will be used in those situations. Now, whatever may be the scale which may be using, either enlargement or reducing, if the size of the object is 100 millimeter, I am reducing it to 50%. It does not mean that I am going to write 50 millimeter. If I am reducing it to 25%, that is 1 by 4, I am drawing only 25 millimeter. You see, this is the big size pencil. If I don't have space onto my drawing sheet, I'll draw 1 by 2. 1 by 2 means half. It does not mean that I'll be writing down 50 millimeter, though I am drawing 50, but the actual size to be manufactured is 100 only. So I have to write the actual dimension on the drawing which I am drawing over there on the piece of paper. So actual size of the component will be mentioned onto my drawing sheet, irrespective whether I am drawing it 50% size or I am drawing it 25% size. Similar thing applies to the enlargement scale. If my size of the component is 2 millimeter, I draw it 100 times bigger, that is 200 millimeters. So even if I am drawing a component 200 millimeter long, but the actual size of the component is only 2 millimeter, it is only for the purpose of elaboration or detailing, I am going to draw it bigger or smaller. So the size on the drawing will be same as the size on the object. So this thing must be remembered for all practical purposes. Now these are the set of scales, once again governed by BIS 10713/1983, which are standard available. You see, every time you cannot keep on reducing or multiplying the dimensions 1 by 50, 1 by 70, 70 by 1 or like that. So standard scales are available with you, so that those scales will facilitate you to use reduction in the drawing at a convenient pace. That is, rapidly you can use those scales. You see, 8 standard scales, they are available. They can be made of cardboard, steel or plastic. So M1 scale contains of, you see, on any scale there are two sides, left side or right side. On one side it is 1:1 scale, on the other side it is 1:2, 50% reduction. M2 scale 1:2.5, 1:5. M3 scale, it gives you the reduction of 1:10, 1:20. M4 scale gives you reduction of 1:50, 1:100. M5 gives you reduction of 1:200, 1:500. M6 1:300, 1:600. Similarly, M7 gives you reduction of the level of 1:400, 1:800. Similarly, M8 gives you reduction of 1:1000 and 1:2000. Now you see how to use these scales. That is, in M8 scale, 1 meter will be represented as 1 millimeter. Similarly, on the other side, where 1 to 2000 reduction is there, 1 meter will be represented as 0.5 millimeter. So here you can see M1, M2, M3, M4, M5, M6, M7 and M8. So on both these sides you can see the reductions are given. 1 is to 1000, 1 is to 2000. So this scale will facilitate you to reduce the dimensions very conveniently, so that without having to multiply, divide and then find out how much you want to draw, straight away this gives you the reduced dimensions as per your convenience. If you have to measure 2 meters over here, you have to draw only 2 millimeter using this scale. So if you draw 2 millimeter over here, it will represent 2 meter onto this scale. Similarly, you can use any given scale, which is a convenient method for drawing the engineering drawing. As I told you earlier, there were markings given on the sides of the sheet. This is for the folding. For every size of the sheet, you see different sizes of sheets we have discussed. This is A4, A3, A2, A1, A0. So there are different folding patterns which need to be followed. So these are the markings which are given on any given size of the sheet. So wherever the dots are there, you can fold the sheets in a proper manner, so that all these folded sheets, they can be conveniently stored in the folders or the files which you can keep in the cabinets or the racks into your engineering division. So through this discussion, we have tried to cover different types of the standards which must be followed in the engineering drawings. So we are still left with two standards. One is the Gothic lettering, and another one is type of lines, which we are going to take up in the subsequent discussions. So thank you very much. So I hope you have developed proper understanding regarding the different standards which are used in the engineering drawing, and by using these standards you will be able to make sure that whatever drawings are available with you, you are able to read them properly, you are able to interpret all your drawings properly and efficiently without any errors. So thank you very much. With this, we end the discussion regarding the standards used in the engineering drawing. Thank you very much.